Good morning, grade 9s, and welcome to a recap on factorization that we did early in the year. We're going to have a look at how to establish the HCF, or how to work with the highest common factor. We're going to have a look at the difference of two perfect squares and the Okay, let's firstly have a look at the highest common factor. So remember, factorization is the inverse of simplification or distribution. So if I had to say to you, simplify the following, you would say, oh, that's easy. I'm going to distribute that 4 into the bracket, and you're going to say 4 times x plus 4 times x is 4x plus 4 times 2 is 8. All right. So now the inverse of this, or the opposite of this, is factorization, where you are going to start with 4x plus 8, and you're going to take out a highest common factor. So if I say to you, factorize the following, and I give you the expression 4x plus 8, then you're going to say, what is the biggest number and what is the most variables that I can take out of both of these terms over here? So if you look at the 4 and the 8, the highest common factor of 4 and 8 is a 4. So you can take out a 4. And can I take out an x here? Yes. But can I take out an x there? No. So you can only take out a number, and that would be 4. So if you take out the number 4, what you're going to do is you're going to divide each and every term, because remember, we distributed in, we multiplied in. So what is the inverse of distributing or multiplying? It's division. So whatever you took out, you divide each term with that number. So you're going to divide 4x with 4x with 4, and what is left? An x, plus 8 divided by 4 is 2. So that is the factorized form. So why do we do this? People always ask, but ma'am, why do we go back and now, do the inverse of this now again? It's to simplify an expression more fully, okay? So why do we do this? Let's just have a look. So if I say to you 4 plus 2 divided by 2, please, people, if you've got two terms on top of that fraction, you cannot just say, oh, the 2 divided by 2, that cancels out, and my answer is 4. Because indeed, 4 plus 2 is 6. 6 divided by 2 does not give you 4, but it does give you 3. Okay, so you cannot do that. So let's say if I take 4 plus 2 divided by 2, and you can say, but ma'am, you can just simplify the top. But what if you add variables there and you cannot simplify the top? You want to simplify it even more, but there's no way of adding the top. So you're going to factorize the top. So I'm going to take out a 2. If I take out a 2 with 4 plus 2, I take out a 2. Remember what you take out, you divide with every term, and then that will give you what is left inside the bracket. So 4 divided by 2 gives you 2, and 2 divided by 2 gives you a positive 1. So now you can say, I'm going to delete those two 2's. Why? Because I created on top here one term. Can you believe that this is one term? But then you say, oh, but ma'am, terms are separated by plus and minuses. We've learned this in grade 8 or even in grade 7 already. Okay, but then you say, remember, a term is separated by a plus and minus unless it is inside a bracket. So now that becomes one term. So we've got one term divided by another term, and then you can cancel out there, you can cancel out there. And then your answer is 3, which is correct. Okay, let's have a look at a few examples with the highest common factor. All right, so please remember, if you cannot see one of the others, your first port of call is to see whether you can take out a highest common factor. So it's very important that you understand this. Right, let's have a look at these two terms. What can I take out from both of them? Okay, so if you look at the numbers first, there's a 3 and there's a 6. So the highest number you can take out there is a 3. Then you go to this term and you say, oh, there's 2 x's there. Can I take out 2 x's from both of them? No, because this one only has 1 x. So then you ask yourself, can you take out 1 x from both of them? Yes. So the highest variable you can take out there is 1 x. So you normally go with the one with, you take the variables and the one with the lowest exponent. Okay. So we're going to take out 3x. So 3x You divide it, so that's 6x divided by 3x. 6 divided by 3 is 2, and x divided by x is 1. 2 times 1 stays 2. Negative divided by positive is a negative. X squared divided by x is a x. So there you fully factorized that expression. Okay, let's have a look at this one. No variables there, so you can't take any variables out, but I can go and take out a nice number because they're both multiples of 5, so I can take out a 5, and what is left? 10x divided by 5 is 2x, negative 5 divided by 5 is negative 1. There, you're fully factorized. Okay, variables not the same, so you can't even think of taking one out, but there's a 6 and a 9. What are factors of 6 and 9? It is 3. Okay, so you take out a 3. 6r divided by 3 is 2r. Negative divided by positive is a negative. 9 divided by 3 is 3s. Okay, fully factorized. Let's have a look at this one. Easy to see. The numbers, the biggest number you can take out there from all of them successfully without leaving a fraction or an integer number. Sorry, not an integer, a fraction. You must be left with a whole number. Okay, is 2. So you can take out 2 over there. Yeah, I can take out 2 from everyone. So how many x's? This one's got 4 x's. This one's got 3 x's. This one's got 2 x's. So what is the most x's that you can take out from all of them successfully? Is 2 x's. Okay, can you see all of them have 2 at least? All right, so I'm going to take out 2x squared. So you take each and every term and divide with what you've taken out. So 2x squared divided by 2x squared is 1. 4x to the power 3 divided by 2x squared. 4 divided by 2 is 2. X to the power 3 divided by x to the power 2. Remember, if you divide, you minus those exponents. So 3 minus 2 is 1. Negative divided by positive is a negative. 6 divided by 2 is 3. X to the power 4 divided by x to the power 2 gives you x to the power 2. And there it is fully factorized. Last one. Okay, take out a 5. How many x's? 4 of them. Okay, can you see immediately that one's got 6, this one's got 5, this one's got 4. So the most that I can take out is 4. So I'm going to take out 5x to the power 4. Divide each term with that term that you've taken out. 5x to the power 4 divided by 5x to the power 5 divided by 5x to the power 4 is just an x, plus 10 divided by 5 is 2. X to the power 4 divided by x to the power 4 is 1. 2 times 1 just stays 2. Negative divided by positive is a negative. 20 divided by 5 is 4. X to the power 6 divided by x to the power 4 is x to the power 2. Okay, and there it's fully factorized. I hope you understand the highest common factor, and if you don't, otherwise after this, please reach out to your teacher. Okay, let's move on to the difference of two perfect squares. So the hint is in the name. It's the difference, which means it's a minus of two perfect square rootable numbers on each side. So very important, has to have a minus in the middle, and both sides has to be perfectly square rootable. And that is why we taught you how to square root with an exponent. And do you remember, how do you do that? Inside over outside, so that you can factorize now. Okay, so very important. NB, it has to be a minus. You always set up your two brackets, always, and it's always in the middle there, and it doesn't matter which one comes first, a minus or a plus and a minus. Okay, for the first part in your two brackets, that first space, you square root x to the power 2. The square root of x to the power 2 gives you x and x. The square root, now for the second term, takes the second space. The square root of 16 is 4 and 4. Okay, all right. So exactly the same. Your brackets are going to look exactly the same. Instead, in the one, there's going to be a minus. In the other one, there's going to be a plus. And again, it doesn't matter which one comes first. All right. Let's quickly have a look at a few examples. Okay, immediately, if you see two terms, two terms with a minus inside. You think, isn't this a difference of two perfect squares? And if they're not perfectly square rootable, ask yourself, can't I take out an HCF first and then do a difference of two perfect squares? Okay, but let's just have a look. These are all straightforward difference of two perfect squares examples. So can I perfectly square root 16x to the power 2? 16, remember the number, you square root as normal, and the exponent is inside over outside. So it's going to be 4x, yes. And can I square root 25y squared? Yes. The number as normal, 25 squared is 5, and y squared inside over outside is y. So always two brackets, minus plus, or plus minus, it doesn't matter, and you square root that number, that takes the first position, square root that number, takes the second position. Okay, just to show you again, remember it's the square root, so the square root of 16x squared is 4x, takes up the first position, and the square root of 25y squared is 5y, takes up the second position. Okay, let's have a look at this example. So please remember a 1. If you see a 1, the square root of 1 is 1. So if you see a 1, it's most definitely a difference of two perfect squares. So always remember, keep that in the back of your mind, that the 1 is a perfectly square rootable number. Okay, so two brackets, minus plus. In your first position, you're going to square root the first term there, 9p to the power 2, the number as normal. What is the square root of 9? It's 3. And p to the power 2, inside over outside, 2 divided by 2 is 1, so it's just p. And then the square root of 1 is 1 and 1. Okay, let's have a look at this one. I'm going to write the number down just so that I can show you. Okay, if you square root this first term, always, remember always your brackets, a minus and a plus. Then the square root, the number as normal, which is 6. A, 6 divided by 2 is 3. B, 2 divided by 2 is 1. Exactly the same in both brackets. Okay, I remember a few years back or last year, you did it once. You only made one bracket, and then you know that is not at all true. So please remember, it's two brackets. That's exactly the same, except for a minus and a plus in the middle. Okay, square root of 121 is 11. C, inside over outside. Remember, there's a 2 that we can't see. 4 divided by 2 is 2. Okay, and there's your answer.